We're going to solve systems of equations now by eliminating one of the variables from the pair of equations. My first problem I have right here is solve this system, and I have x plus y is equal to 3, x minus y is equal to 1. Notice that if I add the left sides of the equations together and the right sides of the equations together, that y plus negative y will be 0y. So I'm going to simply do that. X plus x is 2x, plus 0y is equal to 3 plus 1 is 4. Divide both sides by 2. X is equal to 2. This is the x-coordinate of the point where these two graphs intersect. I'll take that value of x, substitute it back into either equation, and solve for y. 2 plus y is equal to 3. Y is equal to 1. That's the y-coordinate of the point where those two graphs intersect. So the solution to that system is x equal 2, y is equal to 1. So you can check this too if you want by graphing this line and graphing this line. You'll see that they intersect exactly at the point x equal 2, y equal 1. This method right here is really just an application of the addition property of equality. Let's try another one. 3x minus y is equal to 4. 3x plus 2x plus 2y is equal to 24. If I add them the way they are, that is the left sides and the right sides, nothing will be eliminated. But if I multiply this top equation right here by 2, I'll end up with 6x minus 2y is equal to 8. I multiply both sides of this equation by 2. That's the multiplication property of equality. Let's leave this equation the same. 2x plus 2y is equal to 24. Now when I add the left sides together, 6x plus 2x is 8x, negative 2y plus 2y is 0, and 8 plus 24 is 32. Divide both sides by 8, x is equal to 4. That's the x-coordinate of the point where those two graphs intersect. I'll substitute that back into this equation, and I have 2 times 4 plus 2y is equal to 24. That's 8 plus 2y is equal to 24. Subtract 8 from both sides and have 2y is equal to, what, 16? Then divide both sides by 2, y is equal to 8. That's the y-coordinate of the point where they intersect. The solution to that system is the ordered pair x equal 4, y equal 8. That is the solution to that system. So sometimes I have to use that multiplication property of equality first to get the coefficients of one of the variables to be opposites of each other. Let's try another one. 2x plus 9y is equal to 2, and 5x plus 3y is equal to negative 8. Let's see, if I multiply this equation right here by negative 3, I'll have negative 9y here. I can add that to that 9y and I'll have 0. Negative 3 times 5 is negative 15. X minus 9y is equal to negative 3 times negative 8, positive 24. This equation I'll leave the same. 2x plus 9y is equal to 2. Now, add the left sides together. 2x plus negative 15x is negative 13x. 9y plus negative 9y is 0. And then 2 plus 24 is 26. So I have negative 13x is equal to 26. Divide both sides by negative 13. X is equal to negative 2. That's the x-coordinate of my point of intersection. Let's substitute that back in here. And I end up with 5 times negative 2 plus 3y is equal to negative 8. Negative 10 plus 3y is equal to negative 8. Add 10 to both sides. 3y is equal to 2. Divide both sides of that equation by 3, and y is equal to 2/3. That's the y-coordinate of the point where those two graphs intersect. So the solution to my system is x equal negative 2, y is equal to 2/3. This method of solving systems of equations is sometimes called the addition method, sometimes called the elimination method, because we eliminate one of the variables from that pair of equations.